Okay, so good morning everybody. Thank you for joining us for this Deltaee webinar on our consulting projects. We'll be starting the webinar shortly. I'm just going to give a couple of more minutes for people to join us on the phone lines and through the web. We've got a good number of people starting to join now, so I'll go quiet for a minute. I'm going to mute the line and let a few more people join us, and we'll kick off very shortly. So good morning everybody, this is Jennifer at Deltaee Energy and Environment. You've joined us for our webinar on our consulting projects for network companies, including the Freedom project. We're going to be kicking off shortly. There's still a few more people joining us. If you want to make comments throughout, we're very interested in your questions, and there should be a drop-down menu on the right-hand side of your screen, and if you can type any questions in there, that would be fantastic. If you could also just confirm that you can hear everything okay, that would help us out as well, just to double check that it's all running smoothly. And we'll be back with you shortly. Okay, good morning everybody. I think it's a time to kick off now. Conscious that we've got quite a lot of interesting findings to share with you today. Welcome to those of you who just joined us. A few more have just joined the line. This is a Deltaee Energy and Environment webinar on our network consulting projects, focusing a little bit on our recent work as part of the Freedom project. So we'll just kick off now. So welcome everybody. You've heard a little bit from me already, but I am Jennifer Aaron. I'm a Principal Analyst at Deltaee, and I'm joined today by my colleague Will.
Hi everybody.
And we also have with us to talk through the Freedom project, Oliver from Wales and West Utilities. Oliver, do you want to say hello to everybody and we'll check the sound's working properly?
Yep. Hi everybody.
Okay, so Oliver's going to join us and talk through some of the content throughout, but also for a Q&A at the end. So if you have any questions, on the right-hand side of your screen there is a questions box. So please send them through and we'll try and get to them at the end and leave 5 minutes for question time. Okay. So in terms of what we're going to cover today, we're going to give you a little bit of an introduction to Deltaee. A lot of you may know us already. Some of you may not be so familiar with our work, so Will give us a quick intro. We're also going to give you an introduction to the Freedom Project, why it's such an important and critical project for the networks, and where we are in terms of the work that we're doing on the project and the project as a whole. We're going to discuss some of the network and system benefits of hybrid heating systems. This is taken from both the Freedom Project and some other work we've done for network companies. Before looking at the customer experience, so will customers really engage with hybrid heating? And like I said, we'll have some time at the end for some questions. So over to Will.
Thanks, Jennifer. So yeah, many of you on this webinar will know who we are. So for those of you who do and have heard it all before, please just bear with us as we give a quick overview of Deltaee for those who don't know us. So Deltaee is a hybrid research and consultancy company, which is based in Edinburgh and has an office in Cambridge and associates based around Europe and Asia. The aim of our business is to help clients successfully navigate the energy transition from old to new energy. And as one can see, new energy is more distributed, it's lower carbon, it's service orientated, customer centric, and we believe that the real value is downstream as opposed to upstream. Now, looking at the Venn diagram on the left, our main knowledge areas cut across the utility value chain, and this means that we have a large range of clients from network companies to manufacturers to energy suppliers. So how do we go about achieving our core aim? And we do this by providing clients with annual subscription research services and knowledge-based consulting. And we believe that these two areas really complement each other. So the research services can be broken down into 4 core areas: heat, digital, distributed generation and flexibility, and electric vehicles and electricity. The electric vehicles and electricity is a new research service, and it's going to be launched with 2 multi-client studies at the beginning of 2018. And the new energy business model research services, which sits across these 4 areas. The knowledge-based consultancy is bespoke consulting in the listed areas, so market analysis and forecast, strategy, demand forecasts, etc. Jennifer and I are both on the consultancy team, and if there are any further questions about Deltaee, then please don't hesitate to get in touch with us. So we have a growing team of network experts at Deltaee, with the 2 primary experts being Stephen Harkin and Andrew Turton, and their contact details are below the pictures. So we have worked on a variety of network projects, which meeting a number of different needs for both electricity and gas distribution network operators. And these projects include demand modeling, understanding flexibility, price signals and optimization, and future forecasting.
Okay, thanks, Will. So more recently, we've been taking part in the Freedom Project with Wales and West Utilities and Western Power Distribution. It's a really exciting project to be a part of. It kicked off in 2016, so we're well down the road of getting through the project. And the Freedom Project itself is a large-scale demonstration of smart hybrid heating systems. And it's groundbreaking in the sense that it's one of the biggest trials ever undertaken in the UK of hybrid technologies. It has a cross-section of a number of different participants and types of homes, so we're getting a real flavour for how these systems could perform. It also combines the energies and efforts of both the gas network system operators and the electricity network operators. So it shows a real combined effort by the part of the industry here. We've obviously got Wales and West and Western Power, who are very engaged with the project. PassivSystems are providing their smart hybrid controls and project managing the project. And then ourselves, Imperial College and City London are supporting in terms of doing some network impact modelling, data analysis. City are looking at consumer trust and technology adoption, and our part in the project has been largely around looking at technology and markets. as well as the customer research. So we've done a number of surveys with the participants. We're also engaging with them on business models and how to take these technologies to market. So onto the main body of the webinar now, and some analysis of some of our network projects to date. One of the key questions when you're thinking about hybrid heat pumps is why have them at all? Why do we need a hybrid heating system? And a lot of our research has highlighted that they can have a really valuable role to play in the future as the grid decarbonises in the UK. So Will, I think you're going to talk us through some Electricity Northwest findings.
Yeah, so this slide was taken from a previous consultancy project that Deltaee and Electricity Northwest were involved in. And the project involved developing new load profiles for heat pumps and to analyze the impact that the uptake of these heat pumps would have on Electricity Northwest distribution network until 2050. So this top graph looks at the increase in electricity demand for an average winter day, and there are two key points that can be taken from it. The first one is that heat pumps are generally treated as a homogeneous technology, and therefore there's generally just one load profile that's generated for heat pumps. But as you can see from this graph, that's incorrect, and there isn't one standard load profile out there for heat pumps. And they're actually, depending on the type of heat pump, the type of dwelling, the location of that dwelling, which affects outside air temperature, there are various load profiles that can be drawn. The second point is that if heat is electrified, which will occur to a certain extent if there is an uptake of electric heat pumps, then at a household level, the electrification of heat could increase peak load demand by approximately 2.5 kilowatts. So let's now take a look at the bottom graph. So this increase in peak load demand means that the network infrastructure would have to be upgraded to accommodate the additional load. However, when one sizes the distribution network, you have to look at the worst case scenario. And this is a 1 in 20 year winter day. So in this situation, the backup heaters of electric heat pumps will be operating because the load demand will be a lot higher. And the backup heat is approximately 3 kilowatts. So this results in an additional 3 kilowatts of electricity demand, which usually occurs at peak periods. So we can see this effect on the bottom graph, where the increase in peak load demand is now approximately 5.5 kilowatts per household. So zooming out from a household level to a network level, this increase in peak load demand translates to a peak increase in Electricity Northwest network of up to 3.5 gigawatts based on a high uptake of heat pumps. So to put this increase of 3.5 gigawatts into context, currently on Electricity Northwest network, the current peak load is 4.5 gigawatts. So this is an additional 88% load, and which will result in network investment costs of potentially up to billions of pounds, as the network needs to be adequately sized to meet the extreme winter peak. So this is where hybrid heat pumps are really, really useful. So if you look at the flat blue dotted line on the bottom graph, you'll see that the increase in peak load demand is 0 kilowatts. And that's because at a certain point, the heat pump part of the hybrid heat pump stops operating, and the boiler part of the hybrid kicks in. So therefore, hybrid heat pumps can help to flatten out the peak load by switching fuels from electricity to gas at times of high stress on the network. So the network benefits of hybrid heat pumps are clear. However, not much research or work has been done in terms of optimizing the fuel switching ability of these hybrid heat pumps. And this is what the Freedom Project is all about, investigating with field trials how the operation of hybrid heat pumps can be optimized to provide maximum benefits.
Okay, thank you, Will. So one of the challenges that the network has isn't only about the peaks and managing the peaks, it's also about the network and the availability of intermittent renewables. So I'm going to bring in Oliver now to talk us through this chart. Oliver, can you hear me?
Yes, Jennifer. Thanks. Can you hear me?
Yeah.
Can you hear me, Jennifer?
You can carry on.
Yeah, we can hear you, Oliver, so go ahead.
Okay, great. So previous hybrid work has been primarily looking at switching between the appliances based on the coefficients of performance of the heat pump, but not bearing in mind so much the availability of renewable electricity. And so as part of the work with Freedom Project, Imperial have been looking into when you should run the heat pump and when you shouldn't, based upon the availability of renewables. And so when the intermittent sources aren't there that are weather dependent, it is more efficient and lower cost to the consumer to run the boiler for heating, rather than to have peaking gas-fired generation as a flexible source, inefficiently burning the gas, then with line losses down through to the heat pump. And on top of some previous modelling work that's been done using our Pathfinder 2050 model in Cornwall that you may have heard about, we decided to have a look at the Swansea City region because of the extra interest around there with the potential for the Swansea Bay tidal lagoon coming up. So we wanted to compare the profile of intermittent renewables in 2030, December in 2030, compared to the demand. And so we took a demand profile that was made up of the December 2016 electricity demand, the gas heat demand, and also a demand profile assuming everyone in Swansea had an electric vehicle that they would charge without constraint on when they charged. And so combining all that demand up for 2030 Swansea, we were presented with a peak requirement of just under 1,100 megawatts, just under 1,100. And so we upscaled the renewables capacity for wind and solar, multiplied by 5 times the UK Committee on Climate Change high deployment scenario for 2030. So a generous upscaling for wind and solar. And we included the capacity of the tidal lagoon in there as well. And we used the Laurence tidal barrage to provide profile data for us. And so overall, the capacity from the wind and the solar and the tidal lagoon was comfortably meeting the overall demand, exceeding it to about 1,300 or so megawatts if they're all providing at their capacity. However, if the purple line on the graph there shows the profile of that upscaled renewable, those renewable sources, using the December 2016 profiles available to us. And you'll notice that compared to the blue line, there's a significant gap between demand and supply. And just to pick on a couple of those parts of the graph and the reasons for that. The first week or so of December last year was not very windy at all. There was little sun because it was a low sun angle and fewer daylight hours, obviously. But also it was a period of neap tide. And so that's why there was very little coming in when the demand was high in that first part of December. And then when you move to Christmas Day, the upscaled generation for 2030 is just about meeting Christmas Day, and that's because demand on Christmas Day comes right down. You've got very few people in work and lots of people coming together obviously on Christmas Day and sharing the same, sharing their demand in fewer homes. And it was a very windy Christmas as well. You may have seen the Guardian article that came out at Christmas, just after Christmas, before New Year. So it was the greenest Christmas day ever, and that's because it was a very windy Christmas day, and the demand is very, very low. So you can see just on this graph, with the very generous upscaling of renewables, that you have significant gaps still between supply and demand, and the opportunity there is presented for switching between renewable electricity sources through the heat pump, and when that's not available, switching to use the gas boiler, and the gas in the system becoming greener. And interesting, Imperial's research has shown that that switching on this basis and just assuming fossil gas is lower cost and lower carbon for the consumer in the future, and so green gas would provide an even greater benefit. Okay, Jack.
Yeah, thank you. That's really interesting. I mean, just to summarise from my side, I guess for us this highlights that there's just a huge challenge for networks around balancing the supply and demand. So even with renewables maxed out, the profiles won't match, and I guess this is where residential heat can really play a big role. Is that something that you guys are agreeing with?
Yes, absolutely. Chris Clark's also here. We've got the benefit of Chris, if you'd like to come in.
Yes, certainly. I think where the networks would suffer is particularly on the basis of calculating just how much alternatives would be required, and particularly looking at potential storage. That same Swansea simulation would have required 34 gigawatt hours of storage, which is such a huge amount that actually using green gas as an alternative would be a certainly more practical and a much more cost-effective solution.
Mm-hmm. Okay, so yeah, it becomes a really critical question as we look towards decarbonisation. Okay, thank you guys, and that's really interesting. I'm going to move it on now because of time, but we'll come back to this, I'm sure, with questions at the end, because it's a really, really key point. And it also brings us nicely on to the next slide that we're showing here, which is actually, okay, so let's say that hybrid heating systems have a critical role, and I think everyone has agreed that they can potentially play a very important role. And residential heat in particular is a really big problem when you look at decarbonisation, because customers are so used to having just a very simple technology in their homes and a low-cost technology in their homes. And the hybrid project that we're doing with Freedom is really all about optimization and how you can optimize different heat pumps or heating systems, I should say. And this chart here shows some of the ways that a hybrid heating system can be optimized. So the blue line here is a typical gas boiler, showing gas demand going from the cold temperature in the blue to the warm temperature in the orange. And you can see it's a very linear relationship. It's an easy to predict relationship at present. However, in the future, if we do have hybrid heating systems in residential properties, which for our examples here has been an air source heat pump combined, there are definitely opportunities to influence whether the boiler or the heat pump part is operating in times of peak demand or when there is excess of renewable generation. There are a number of ways the system could be optimized. In general, if left to their own devices, at lower temperatures, the gas boiler will kick in, and at higher temperatures, the heat part of the system, the heat pump part of the system will work. So far, relatively straightforward in predicting gas demand. However, there's a large area in the middle of mid-range temperatures where there's uncertainties, or you might call it opportunities, to influence operating patterns of heat pumps. And this is where it would be harder for gas networks to predict their demand. So it's in this mid-range area, like I said, where the Freedom project is really exploring different optimization options available. And it can be optimized by energy price or carbon intensity or other factors. So the curve at A here illustrates a potential pattern where there is a lower electricity price or availability of lower carbon electricity. So the heat pump is instructed to work for longer and at potentially a lower temperature than it would do ordinarily. Point C is the converse relationship, so it's a curve that shows that if electricity prices were high, or if there was a period of high carbon intensity on the grid, a gas boiler might be a preferred option, even in a temperature range where a heat pump is relatively comfortable working. Point B is obviously if you set a defined point for switchover. So this could also be done through the control system. So you can maybe automatically set the system to preheat your home using the gas boiler or give an initial boost. Lastly, the spikes that you see at points D are examples of what might happen if there are one-off events which could influence performance. So if there is a dip in the use of gas demand on a very windy day, for example, it's the first one. I think overall what it's really critical to highlight is that it's not a linear relationship. And as we saw with the work for Electricity Northwest, there'll be a variety of different load profiles the networks will need to be able to consider. It also highlights that there's work to do. Under current energy prices, this sort of optimization isn't possible, as the system will always choose the gas boiler in most cases. But if the price signals are right, hybrid heating systems have the potential to be both lower carbon and lower price for the consumer than other solutions. So there's work here for policymakers in supporting energy companies to develop more innovative tariffs and to exploit these opportunities, or ensuring the relative cost of electricity is lower in order to progress towards decarbonisation. Anything to add, Will?
No, I think you explained that really nicely. So yeah, just I guess the saying in that white zone where there's opportunity for both technologies to operate presents a really good opportunity to optimize the system depending on those factors that you mentioned, such as the electricity or gas price or the carbon intensity.
Okay, so just conscious of time, I'm going to move it on now to talking more about the customer research, because I think one thing that it's sometimes easy to forget when we're talking about the potential for new heating systems is how do we get customers to really engage? And the Freedom Project gives us unique insight into how customers will behave with the technology, how they will interact, and how easy they are to persuade to take a technology. So it's worth spending a little bit of time here, I think, in understanding customer attitudes. In general, we've done a lot of research with customers over the last 5 years through our Heat Insight service and more latterly through our Smart Energy Customer Panel. So Deltaee has its own customer panel with 1,000 homeowners. So we regularly ask them what they think about technologies and innovations coming down the line. Unfortunately, consistently, awareness of hybrids heat pumps has been low, and it's not improving. So year on year, there's no improvements in awareness seen here, and it lags behind other technologies. And this obviously presents a major challenge to any kind of mass rollout of a technology. Customers don't know their options, and they can't select that option at the point when their boiler breaks down. More positively, however, when we explain the technology to people, they're very engaged. And this is the same for the group of people that have participated in the Freedom Trial. So we see, especially in more recent years, the appeal of the technology has shot up hugely. So it's now actually ahead of ground source heat pumps in terms of the level of appeal in the latest 2016 results. And it's almost up there as far as kind of solar PV, getting close to those sort of numbers. So the technology has huge potential in terms of customers finding it an appealing technology to install in their homes. In terms of Freedom, what we have is a really unique insight into a whole range of different property types and customer types. It's demonstrated that it is feasible to install these technologies in a cross-section of different property types. So what we have is a mixture of properties, from large properties to smaller properties, from new builds right down to older properties. And we haven't included any additional insulation as part of the installs. So it's really just using what's existing there, and it uses the existing wet heating system as well. So there's no additional work's been carried out. It just demonstrates that actually these technologies can be retrofitted into these kind of mixed property ranges. We also have a mixture of social and private tenants, and I think as it goes on, it will become clear that this how these people engage with the technology, whether there's any differences. Generally speaking, we find that social housing tenants are much more concerned with running cost savings for obvious reasons, or maintenance, and Will's going to talk about that a little bit more later. We've also installed 3 systems off gas as part of the trial, which is a really unique So we've installed 3 systems with LPG, and we've included one where we retrofitted an air source heat pump onto an existing boiler. And when I say we, I mean Passive. They've been doing all the hard work with the trial, and we've just been speaking to the customers. And also, lastly, just to point out that we've covered the project covered a wide range of different property types in different areas. So it's all focused around Bridgend in Wales, but we have a mixture of kind of urban, suburban, rural, semi-rural properties. So it really is a great cross-section of kind of, a representative sample of UK homes in which to kind of build assumptions from.
So, in addition to the great diversity and representative UK homes that we have got for the trial, the customer profile of the people is also really representative of the UK. So it's a great sample to have. And a few interesting things to note is that the sample seems to be greener than the UK average. And they also seem to be more energy smart and engaged with their heating. And for the reason why we say they're energy smart is that 40% of them said they already use an app to control their heating. But given that in reality they are only using really simple control protocols, such as selecting the time of day when their heating goes on. So take from that what you will. With regards to their expectations, unsurprisingly, the primary expectation is to save money from the trial, but it's also really encouraging to see that the customers also want to save energy. That's also one of their priorities. Now to talk about the installation, we did a pre-trial survey to kind of get the customer's viewpoint of the installation, and it was really encouraging to see that less than 30% of them had concerns about the technology, so the hybrid heating system, and less than 10% of them had concerns about the installation. So that really highlights the fact that engaging with the customer pre-installation and providing education and information to them is really important in terms of getting them on board. So we can really say that the installation process has been a success. There's been hardly any complaints or concerns so far, but we are aware that the real test will be coming this winter, so the next couple of months. A few important points to note is that different demographics had different concerns. So, for example, the older demographic had higher concerns about the hassle that the installation will provide, and a lower income group understandably had concerns about the increased maintenance costs. So what are the lessons learned from this? Firstly, holding the customer's hand from beginning to end of the service is really important, as well as providing information and education about this technology, because it is quite a new technology. It's quite novel. People aren't, as we have seen, very aware of it. So providing as much prior information and education is extremely important. And building on that, ensuring that system performance is guaranteed, because there's not much knowledge about this technology. People are obviously a bit wary of it. So reassuring the customers and offering assurance about the performance of the system is very important. And as one would expect, providing the hardware for free is obviously a big draw.
Yeah, thanks, Will. I mean, in terms of the running cost guarantees or maintenance guarantees, this is something that we found on a consistent basis with our customer panel research, is that even though a hybrid heating system usually combines 2 very mature technologies that shouldn't have additional maintenance requirements, there's a perception that it's very new and innovative, which on the one hand is great, because we found that participants in the trial were quite excited about having a new and innovative technology in their home, which made them more engaged with it. But on the other hand, they felt very wary that there might be increased maintenance. It felt more like there was risk associated with it. So anything you can do to remove that risk, so bundles, for example, with a maintenance package included, or like I said, a guarantee on running cost savings, which is obviously harder and more risky to provide, is something that would reassure customers going forward. And then obviously, technology for free. So a big part of the project towards the end will be looking at, what business models can be used. And it won't just focus on the customer angle, but from the customer perspective, there's obviously a number of different exciting business models emerging in UK and further afield that could help support hybrid heat pump uptake, or hybrid heating system uptake, I should say. Okay, so I'm just conscious of time, so we've got about 10 more minutes for questions. I just wanted to quickly show you some of the successful installations. So you can see here that there's a variety of different house types. There's 3 different types of heat pump that were installed in combination with the boilers. And you can see kind of some of these, how these looked in these pictures here. Internally, these are some of the internal works. So internally, it doesn't have that much visible impact in the sense that it looks similar to a boiler. And then we've obviously got the controls, which are really important for this. So PassivSystems have launched an app, and that's been used to help with the optimization of systems. Okay, so I'm conscious of time, and it'd be great really to hear more from Oliver. We had hoped that Tom from PassivSystems would be able to join us as well, but unfortunately he's not been able to on this occasion. But yeah, I'm going to unmute you, Oliver, and Chris, because it'd be great to have a bit more of a discussion with you guys. Okay, so we've had quite a few questions in. So one question is, this is one for you, Ollie, Chris. Why are the gas distribution network operators so interested in this technology particularly?
I think why our initial interest was trying to understand what investment we need going forward in the gas network, and should we continue to invest in the maintenance of gas network, and this technology appears to indicate that the gas network would have a very long future based on the significant reduction in the amount of gas that is used. It actually then as well enables the kind of levels of green gas that could potentially be put into the network to be fully utilised, and therefore when we've done some of our modelling using the Pathfinder tool, it can indicate with a combination of hydrogen cities, which the 821 project is looking at, in addition to the use of renewable electricity when available and low cost, along with the use of green gas, can see a model there that indicates full decarbonisation of heat at the minimum cost and the least disruption to customers. So initially our interest was really trying to understand the impact on the gas network. What has emerged from the project and the initial results is the route to decarbonisation here that nobody else had ever thought of, and by using the smart technology could see this full decarbonisation in a way that no one else had envisaged. So it's a real disruptor to the potential change in heating requirements over the years.
Okay, thanks. In terms of other questions, this is an interesting one. Will the forecast gas volumes used by hybrid systems justify the continuing existence maintenance of the grid if deployed at a mass scale? There's one for you guys.
Yeah, we've done an analysis of the gas grid at different pressure tiers. We segmented it into the high pressure system, the medium pressure system, and the low pressure system. And what we see here is the high pressure systems, medium pressure systems will still remain crucial for providing gas to industry and power generation, quite likely with CCS attached to it in the future. But the low pressure system is the area of most interest. And because the costs of operating the low pressure system are dramatically reducing, then we can see the continued use of the low pressure system, transporting that green gas that I just mentioned to consumers for when the renewable electricity isn't available. That's where the Swansea modelling really helped, because we can understand precisely when and in what circumstances the green gas would be transported, and to understand what sort of peak loads might ensue from that. And what we were finding is actually peak load doesn't seem to reduce much. In fact, peak load could even go up with more and more power generation coming onto the gas grid at a distributed level, simply because to balance the renewables that are also on the distribution network for the electricity side. So we've got a rather counterintuitive finding that gas grid use, particularly in the 2020s and early 2030s, goes up rather than down, albeit the annual demand would go down significantly.
Okay, that's interesting. The other question we've had a few people mention is around energy savings and energy bills. Obviously, this is a trial project to look at largely the optimization. But in terms of the impact on bills today, what's the impact on customers?
So for the trial, the customers are expecting to they're told to expect for their electricity bill to be a little bit high, because obviously we're forcing switching signals to use the heat pump when at today's prices that wouldn't be wise without RHI.
Mm-hmm. Yeah.
But looking into the future and the value proposition to the consumer, the Freedom Project is looking at exploring the value streams available. So that's value through arbitrage, buying energy at day-ahead prices and selling heat to service, factoring in the demand of all the aggregators' properties and how that demand may change with weather forecasts, and what the prices the price impact will be on electricity specifically on availability of wind. So the arbitrage value plus the value from demand side response. So that's the frequency response to the properties, to be able to, within the comfort range of each property, to marginally overheat or underheat, depending on whether the network needed to upturn or downturn. So a value from both of those angles. But there's an emerging, it's not part of the Freedom Project right now to understand fully in detail what the consumer proposition is,
yeah.
But an emerging thought around this, which is going to be part of a follow-on project from Freedom, hopefully, which will happen next year, which is looking at how can this be something that the consumer finds attractive, but it's not a force. And in summary, that would be where if someone's got something that's gone wrong with the boiler, they call up the usual person they speak to, whether they've got the peace of mind service with a monthly fee, and they use that to get somebody in, or whether it's someone who calls their usual person who fixes it. Either way, them being an agent of heat service provider, an aggregator, and they can come and say, yeah, I'll fix your boiler, it costs this much for this part, it'll take this amount of time, so the overall price is this and I can do it tomorrow. Or I'll do that for you for free, and then I'll come back in 2 or 3 weeks time and I'll replace your boiler for a brand new efficient boiler. I'll give you a heat, I'll give you the controls and talk you through how to use them. We've monitored your demand through your smart metering. This is what your heat service bill would look like. And then a little while later, when they've got used to it and understand how it's all working, then can be offered a reduction on their heat service bill for the heat supplier and aggregator to be able to grow the arbitrage value by installing insulation that pays back for the consumer.
Yeah.
And so growing that value with the consumer, aggregator and third-party investor in the assets.
There's a real role here then, however, for installers and engaging installers, I guess. I mean, we've done a lot of research with customers outside of this project, and it seems like the preference is still to go through a small local installer. And I think it's the key thing you mentioned there is, capturing these customers at the point where their boiler is breaking down, preferably not when it's broken down. So that's where the kind of monitoring packages you mentioned there kind of will come into play in a big way, I think.
Yes, it gets over the significant unwillingness or inability for consumers to pay that came from Bridgend study on 10,000 properties that's happened over a few phases in the last few years, you may have seen, where 81% were either unwilling or unable to pay for a different heating choice for their home. And so that getting over the capital cost for consumers with heat as a service like this, and including in the package the repair, service, and maintenance of those assets, and maximising the efficiency of their buildings through offering as part of that package installation measures that pay back, then that takes that burden off the consumer. So that's something we're looking to explore in more detail in the follow-on project.
That sounds really interesting. Probably got time for another question. Obviously, we're running to time now. One last question would be about around customers accepting optimization. So from our side, we've recently got some findings back from our panel around customers' willingness to accept flexibility in their systems, and the results are encouraging or discouraging. I don't know. We found that about 50% of people said they would not accept external control. So you could read into that as being a negative, but that means that 50% of people would be happy to relinquish control of their system to somebody else, and that's if the technology stays, the house stays in a kind of comfort temperature for them.
Yeah, I think it depends on if you're a glass half full or glass half empty kind of person, the way you look at that. I mean, I think given that optimization and demand side response is still very new within the UK, I think the fact that 50% of people would be willing to accept that, given that it's very, very new and innovative, is potentially very encouraging. We'd have to put a caveat in there saying that we just got the results back, so we haven't performed any real analysis on it, and this is just a high-level view of it. But from my perspective, I think it is encouraging that 50% of people at this current time would be willing to accept optimization.
And Oliver, from the trial participants, the app and the control system, was that something that was appealing to them? I mean, it's probably a question for Tom at Passive more, but do you have any?
We visited a few properties recently, and there was very positive response from them. And there's one in particular where there was an elderly couple who previously said they've never really been able to experience heat comfort that they would like to, but for many years. And they received an installation as part of the trial, and they are not tech savvy at all, but they get on with it very well. And they notice when the heat pump comes on to build up the temperature early, and then they recognise when the boiler comes on to boost, and then the heat pump maintains the temperature. They've noticed that their radiators are running at slightly lower temperatures, however, they're comfortable all the time. Even rooms that weren't warm comfortable before, like converted garage. And PassivSystems went away from that, checking on the electricity consumption just to see, is there a significant increase in their bill because of the use of the heat pump in the way it was running for them, and it wasn't. So it was actually working as it was meant to, and consumers who don't normally like new technology and complexity were enjoying it and getting on very well with it. So it's really good.
I think an observation for me, particularly about technology take-up, is whilst it's very new to most people, I think there's an assumption in all elements of decarbonisation that consumers will change and they're going to have to change. So, for example, charging smart vehicles or charging electric vehicles, rather, if it's not done in a smart way, that's going to break the electricity grid. And the assumption is that consumers will really have to change their behaviour. Otherwise, decarbonisation on a whole range of fronts, both electricity and transport and heat, will not work. So I think it is a big challenge if 50% of consumers don't want to change. So I think that shows us the way forward of what we need to do to educate consumers about the challenges of decarbonising transport, heat and power.
Yeah, thank you. So just conscious of time, I think we'll have to call time there. There's a lot more questions here, so we'll make sure that we follow up with everyone who's asked a question that hasn't been responded to. So we'll send you an email or give you a call. And yeah, we'll put you in touch with Oliver and Chris where necessary as well. So yeah, thank you for everyone who's attended. It's been great to have your engagement and some really interesting questions coming in. And thank you very much to Oliver and Chris for joining us. It's been really useful to have your insight on this webinar.
Pleasure.
No problem.
Right, thanks guys. Right.